Okay, good morning. This is Professor David J. Delos Reyes. Okay, my topic for this morning will be the continuation of college algebra, and this will now be lesson number 51. Is it 51? Yeah, 51. We just finished the study of exponential and logarithmic functions. Okay, we know already how to graph logarithmic and exponential, and we have solved problems that involves logarithmic and exponential, and we are also through with the application problem. So for this morning, we'll now discuss arithmetic sequence. Okay, the arithmetic sequence or arithmetic progression. Okay, let's proceed. This will now be lesson number 51. This is college algebra, long video format discussion. College algebra lesson number 51. That is after logarithmic and exponential function. And the title of the topic is arithmetic sequence or arithmetic progression. What is arithmetic sequence? Arithmetic sequence, to give you an example, it's just an easy one, like the number 1, 2, 3, 4, 5 up to 20. That is considered an arithmetic sequence. Why arithmetic sequence? The sign of a so-called arithmetic sequence is that there is a common difference. Okay, common difference like the number 1, 2, 3, 4, 5. It is considered to be an arithmetic sequence because from number 1 to number 2 there is a difference of 1, and 2 and 3 got a difference in 1. So under the study of arithmetic sequence, if there is a common difference, okay, that sequence is actually termed to as arithmetic sequence. Okay. So if we will try now to designate the sequence as a sub 1, a sub 2, a sub 3 up to a sub n. Okay, there are problems under sequences in which we are asked to take the summation, meaning the sum from E1, E2, E3 up to E sub n. And under the study of arithmetic sequence, there is the so-called sigma notation. And the sigma notation is given by this equation here. This letter here is sigma, a Greek letter sigma, right? Meaning summation. If I will try to read this one, sigma notation with a lower limit 1 to n. Under the study of algebra, instead of placing it as a limit, they just place it as index. But this is actually synonymous to the study of integral calculus. There is the so-called lower and upper limit. But under the study of algebra, instead of placing it as limit, they place it as just simply index. Index is synonymous to limit. Okay, sigma notation with the lower limit 1 to n, okay, with a small letter a with the subscript I equal to. If we try to simplify this one, if we try to bring out the meaning of this, okay, sigma notation with the limit from 1 to n of a small letter I as a subscript. If we try to expand this one by using this notation, it should be, we take that a, okay, we start with 1, okay, plus a, the next one will be 2, plus the last one will be a with the subscript n. That's the meaning of this. The meaning of that is that the summation of the arithmetic sequence from E1, E2 up to E sub n is designated by this. Designated by this. That is sigma notation with the limit from 1 to n is actually a with the subscript I equal to E1 plus E2 plus up to E sub n. That's the proper way how to read this sigma notation. So from now on, under the study of algebra, if you got a sigma notation like this with the upper lower limit 1 up to n, it is understood that we will be taking the sum of a with the subscript I with this given limit from 1 to n, meaning e1, e2 up to e sub n. So this one here refers to this one here, and this in here refers to the in here. Okay? So it seems we are just placing the value of the given right-hand side. We're starting with 1 up to n. So we start with 1, 2, the last one is n. The lower limit is 1, the upper limit is n. The last one is n. Oh, that's it. That's how to read this sigma notation. Where I is the index, or just simply the limit of summation, n is the upper limit, and 1 is actually the lower limit of summation. Okay? So the number here underneath is the lower limit. At top of the sigma notation is the upper limit. Okay? So it seems we are already on the integral calculus, like in the integral of from, okay, the integral sign from 0 to 1, something like that, right? The lower one is the lower limit, and the upper one is actually the upper limit. Okay, they are synonymous. So under the sigma notation, it follows under integral that there is the lower limit and the upper limit. Okay, I will try to erase this one so it looks good. Oh, that's the sigma notation under arithmetic sequence. This is the way how to take the summation of numbers which are in under arithmetic sequence. Okay, they are in arithmetic sequence if they got a common difference. An example of this, I have seen problems under short videos. It is something like this. Okay, find the sum of the sigma notation. Lower limit will be 1, upper limit will be 7. The given expression is k minus 1. Oh, this is not a hard problem. It's just a direct substitution one. We are just placing the lower limit and upper limit considering this expression here. Oh, that's the essence of it. No big deal about it. Okay? So if we try to simplify to bring out the solution, sigma notation with the limit from 1 to 7 of the given expression k minus 1, meaning to say, for every k, we will place the lower limit, starting with the lower limit, till the upper limit. So by using the expression k minus 1, when k is 1, this should be 1. 1 minus 1, first term. Second term will be the next number after 1 is 2, right? So this should now be k minus 1. K now is 2 minus 1. Third one, the next number after 2 is 3. So this is 3 minus 1. Next one is 4. 4 minus 1. Okay. Next one is 5. So this is 5 minus 1. The next one is 6 minus 1. And since the upper limit is 7, this is 7 minus 1. We stop from there. Okay? We stop. Because this is the upper limit, this is the lower limit. That's the meaning of this. Okay, sigma notation with the limit from 1 to 7 of the given expression k minus 1. So this is just a direct substitution problem, and it's no big deal, right? So this is 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1. Summation. That's why it is sigma. Plus 5 minus 1, plus quantity 6 minus 1, plus 7 minus 1. Then try to simplify. 1 minus 1 is 0, 2 minus 1 will be 1, 3 minus 1 will be 2, 4 minus 1 will be 3, 5 minus 1 will be 4, 6 minus 1 will be 5, and 7 minus 1 will be 7. Taking the summation, it will be 21. So the answer will be 21. The meaning of this, the summation with the limit from 1 to 7 of the given expression k minus 1 is actually 21. Okay? Example number 2. This is under arithmetic sequence. Okay? Find the sum of the summation with the lower limit 4 up to 7 of the given expression, the square root of 2j minus 1. it involves radical sign, right? So this will be square root. So solution, I place it here using vertical addition. I will write the addition vertically, okay? Because if we go horizontally, okay, we will be occupying the third row over here or column. I don't want to do that, so I will add vertically. So I will not go to the third column, okay? So the summation with the lower limit from 4 to 7 of the given expression, the square root of 2g minus 1 equal to, oh, you just follow this expression here, then try to substitute the lower limit first. So this should be, the first one will be 2 times 4 minus 1, right? Okay, this is plus. Next one will, the next number after 4 will be 5, right? So this should be the square root of 2 times 5 minus 1. Okay? What's the next number after 5? It will be 6. So this is plus again. I add it vertically. So the square root of 2 times 6 minus 1. Okay? The next number of 6, after 6 is 7. And that is now our upper limit. Right? So this is plus again. The square root of 2 times 7 minus 1. Okay? So this is the expression when the lower limit is substituted. Okay? This is the expression when the upper limit is substituted. So we got already the terms needed to evaluate the summation of this one. So simplifying, 2 times 4 is 8 minus 1. This should be square root of 7. Okay. Next one, this is 10 minus 1. This should be square root of 9. Next one is 12 minus 1. That will be square root of 11. The last one is 14 minus 1. That will be square root of 13. Since all the numbers are actually irrational, it's not perfect, a perfect square, except for this 9 maybe. Because the square root of 9 could either be plus or minus 3. But I don't want to touch this square root of 9 now. I will just place it as a square root of 9, so they look the same, okay? So the final answer will be the square root of 7 plus the square root of 9 plus the square root of 11 plus the square root of 13. And if you want the exact value, you could use the calculator. Okay? We could use the calculator. If the answer looks for an exact number in terms of decimal, there's no problem. 7, the square root, plus open quantity, 9, the square root, close quantity equals, plus open quantity, 11 square root, close quantity equals, plus open quantity, 13 square root, close quantity equals. So the answer will be 12.56. This is 12.56 by using the plus sign. So it's either plus or minus. Okay? But in terms of irrational expression, they should be square root of 7 plus the square root of 9 plus the square root of 11 plus the square root of 13. 12.56 is almost equal. This is 3. This is 3 plus. This is 3 plus. Plus this. It's 12.56. Okay? That's the way how to, what call this, simplify a summation of terms under arithmetic sequence. That is the summation of a with the subscript I with the lower limit from 1 to n is actually a sub 1 plus a sub 2 plus that the last one will be a with the subscript n. This n here refers to the upper limit and this one here refers to the lower limit. That's the way how to simplify that sigma notation. Okay, let's try to bring out the, what you call this, the how to compute for the nth term of an arithmetic sequence. If a sequence got a common difference or, right, a common difference, it is an arithmetic sequence or progression, right? If we try to compute for the nth term, it is designated by If the sequence is A1, A2, A3, the last one is E sub n, for it to fall under arithmetic sequence, the difference E2 minus V1 should be equal to D, and the difference E3 minus E2 should also equal to D, and A4 minus E3 should also equal to D. And these are all the same, and it is termed to as the so-called common difference for arithmetic sequence or progression, right? So if we try to compute for the nth term is actually A with the subscript n equal to, it should be the first term plus open quantity n minus 1 multiplied by D. Right? So meaning to say, if we are given A1, if we are given n, and we are given D, to compute for the nth term, we use this formula. It will be A1 plus the product of the quantity n minus 1 multiplied by D, where E sub n is actually the nth term, and E sub 1 is the first term, and D is the common difference. Like the sequence 1, 2, 3, 4, 5, right? Or a harder one, 2, 4, 6. And the problem is asking what will be the 20th term. Okay? To compute for the 20th term, we will be using this equation here. That's the meaning of this equation. Okay, let's try to bring out the nth partial sum of arithmetic sequence or arithmetic progression. The summation of an n number of terms under arithmetic sequence or arithmetic progression. To compute for the summation, we will be using the first equation I brought out a while ago. The summation with the lower limit from 1 to n of A with the subscript I should be equal to A1 plus A2 plus A3 plus E sub n. Okay, this was the original equation, right? But there is a simplified equation on how to bring out this one. If we are under arithmetic sequence, and that formula is actually designated by capital letter S with the subscript n, meaning the partial sum of the n terms. Okay? The n here is specified. So if we are having a sequence 2, 4, 6, something like that, and the problem is asking what will be the sum of the 20 terms of that arithmetic sequence, the formula on how to bring out the summation will be this equation here. S with the subscript n will be equal to n over 2 times the quantity A1 plus E sub n plus quantity. That's the second formula. Okay? The first formula is actually by using the longhand method, the one we brought out in our example, right? But there is, that's why we are studying algebra, okay, to simplify our calculation. And to simplify our calculation, there is a formula. That's why we need formulas under algebra. And the formula on how to take the summation, partial sum of n terms under arithmetic progression or sequence, it is designated by n over 2 times the quantity A1 plus E sub n close quantity. That's the second equation. Because the first solution is actually the brute force solution. Okay? Brute force. Because you will be taking summation by using your calculator or by using longhand. The next solution, which is more favorable, is actually this by using this equation here. And the third one will be this. They are the same, but this last one was derived from this second one. Okay, if we try to bring out the simplification of this, it will be n over 2, right? This is A1. And what is E sub n? E sub n is actually n minus 1 multiplied by D. Where is that equation? Where is that equation? It is this, right? The n term is actually the first term plus the difference of n minus 1 multiplied by D. So we will be replacing A sub n by using this equation here. So what will come out? So this is A1 plus A1 times the quantity n minus 1 multiplied by D. This portion here is actually E sub n. Right? And if we try to simplify, there will be 2A1 inside. So the final third equation on how to bring out the summation of terms under arithmetic progression or sequence is with the subscript n equal to n over 2 times open bracket 2a1 plus the difference of the product of n minus 1 multiplied by the close bracket. This will be the third equation. So you could either use this second to the last and this last equation, still you bring out is S with the subscript n, meaning the summation of the n terms under arithmetic progression or sequence. Okay, that's it guys. I think these are just the important terms under arithmetic sequence or progression. At least we now know how to take the summation of the arithmetic terms by using the brute force solution, that is by using our calculator or by longhand. And at least we now know also how to compute for the n term for an arithmetic sequence. And for the summation, there are three solutions. The brute force solution plus this Sn, okay, and the last one will be equal to n over 2 times the open bracket 2a1 plus the product of n minus 1 multiplied by t. Okay, that's it guys. The next time around, I will be giving example problems on how to bring out a problem under arithmetic sequence or progression. Oh, I think arithmetic sequence or progression in real life, it got not so much importance. Arithmetic sequence or progression are just brought out to test your knowledge under the IQ exams. Okay? For the testing of your mind under IQ exams. There are problems, lots of problems under arithmetic sequence, under the so-called, like for example, SAT and CAT exams. Okay? Okay, that's it guys. So for those of you who are taking up college algebra, if you want to subscribe to my channel is youtube.com/ProfDavidJDelosReyes. If you want to share it, please click share. Okay, good morning from Los Angeles, Professor David J. DeLosReyes.